Welcome to the second video in our series on Angular dependency injection. In this video, we're going to take a deep dive into dependency injection and discuss exactly what it is, most of its features, and how we can use it to our best advantage. Whether you're new to Angular or you've been developing with it for some time, you probably already have some level of familiarity with dependency injection. But what I've discovered as an Angular developer myself is that sometimes we can use a particular Angular feature for years on a daily basis, but never really get to know the advanced aspects of that feature. And I have to admit to you that I've been using Angular for a while before I became really familiar with the different features of dependency injection, such as providers and injectors and injection tokens and how those things work. And once I became acquainted with all of these aspects of dependency injection, it really did have a positive impact on the way I code in Angular. And that's what I showed you in the first video in this series on dependency injection, where I showed you how I could do something like console log values from methods in my services without actually modifying the code, the existing code of my service. And my goal in this video is to bring to light some of the things that dependency injection has to offer, and to do that in an easy to understand way so that you too can use dependency injection to your best advantage. First things first, let's define exactly what dependency injection is. And one of the first things that you should know about dependency injection is that it is not Angular specific. In fact, many technologies use dependency injection, including .NET and Java. What all variations of dependency injection are, they're all implementations of the inversion of control pattern. And what the IOC pattern and therefore dependency injection does for us is it allows us to separate the use of a resource from the creation of a resource in our code. And you're going to hear me use the term resource throughout this video because when we think of Angular dependency injection, we tend to think immediately of services, of JavaScript classes. But in fact, we can use dependency injection with values and objects and even functions. So we're not relegated to just using services or classes with dependency injection. So again, you're going to hear me use the broader term resource throughout the video. Now, if dependency injection helps us by separating the use of a resource from the creation of a resource in our code, then that begs a question: how does using a resource and creating a resource in our code pose a problem? So let's take a look at how things would be without dependency injection. Here I have a couple of Angular code snippets. The first is a snippet of a component, and the second is a snippet of a service. The component snippet demonstrates how we would use a service within a component without dependency injection. And the way that we do this is by both creating an instance of the service and using that instance of the service within the component's code. Now, this in and of itself doesn't pose any problem. This code would work fine. That is, until we want to make certain modifications. For instance, if, say, we wanted to change this data service to now take a constructor which is a string value that represents an API URL. Well, if we make this modification to the data service, we would then break our component. And in fact, we'd break all of the components in our application that implement data service in this way. So this is one of the issues with creating an instance of a resource within a consumer's code. In this case, the consumer is the component. Another issue we might see is if we wanted to replace the use of data service within some of our components with a new data service. Well, everywhere we'd want to replace data service with new data service, we'd have to make that modification within our component code. Creating instances of our resources also poses a problem during testing. In order to test the features of this consumer component in, let's say, an isolation test, when we create an instance of the component, we'd automatically be creating an instance of the real data service. During testing, we wouldn't want to start up our real data service and maybe any of its dependencies, such as a backend service. We'd want to mock the data service during the testing of our component. But this implementation doesn't allow for that. It's going to create a real data service whenever we create an instance of the component for testing. So these are just 3 of the issues that we might face in using and creating a resource without dependency injection. I've created a small demo application consisting of 2 components, a display component and an other display component. And each of these standalone components are being used in the root component, the app component. Here, I'm using an instance of the display component, and I've projected into it an instance of the other display component. And I also have another instance of the other display component as a sibling to the display component. So that's what we're seeing to the right of the screen in the browser. We're seeing the display component, the projected other display component, and the sibling other display component. Along with these 2 components, I've created a service, and this service is called Simple Service. And Simple Service is being used by each of the components to set their info observable property. And when the info observable property is set, as you can see here from Simple Service, it emits an object that contains one property, and that's the source property. And Simple Service is passing along this description of the source, which we see in our browser. So that's how the application works. We have 2 components which are displaying the source data from the service. Currently, the application is not using dependency injection. Both of our components are creating instances of Simple Service within their code. And we've already discussed 3 of the issues that this kind of implementation without dependency injection, what this poses. So now let's refactor our components so that they are implementing dependency injection. But let's first take a look at exactly what needs to be done in order to implement dependency injection in this application. There are steps that you have to take in order to implement dependency injection in your applications. And the steps that you have to take can differ depending upon whether your resource is a service, a JavaScript class, or if it's something other than a class, such as a value or an object or a function. So first, let's take a look at the steps we follow to implement dependency injection for a service, for use of a service. The first step in implementing dependency injection for a service is to decorate the service class with the injectable decorator. The injectable decorator tells Angular that this class can be injected or passed in as a parameter to a consumer's constructor. And in fact, if you try to pass as a parameter a service that doesn't have the injectable decorator, you'll get a compilation error. So that's step 1. In step 2, we register the service. When we register a resource, we're telling Angular where we want that resource to be available. There are 2 ways in which we can register a service. The first way, which you see in step 2a, is by adding a provided in property to the injectable decorator's metadata object. When we set the provided in property to root, we're telling Angular that we want this service to be available to consumers consumers throughout our entire application. And Angular will not only make this service available to all the consumers throughout the entire application, but it will also create a single instance of the service, making it a singleton. So that's the first way in which we can register a service. And actually, this method of registering a service is the recommended way to register a service. And the reason that this method of registering a service is recommended is because when we use the provided in property, it makes the code of the service tree shakeable. When code in our Angular application is tree shakeable, that means that when we build our application, if that code is not used anywhere in our application, then it will be removed from the build. And this, of course, is an optimization strategy. Now, bear in mind that while this is the recommended way, it's not the required way to register a service. It's just recommended. And in fact, we have other options. And we see that in step 2b. We can register a service, and in fact, any resource, by adding that resource to the provider's array of either a component or a directive or a module, which is why I'm showing 3 question marks, because the provider's array property exists on any of those classes, a component class, a directive class, or a module class. And we'll get to learn more about this provider's array later in the video. The final step in implementing dependency injection for a service is to actually inject that service into the constructor of the consumer. And a consumer can be a component, a directive, or another service. So there you have it, the 3 steps to implementing dependency injection for a service. Now let's take a look at this in code. Here in the demo application, I'm going to modify the code so that the display component and the other display component are both implementing dependency injection, and I'll have both of them use the display service instead of the simple service. So first, I'll comment out the implementation that creates an instance of the service within both components. So I'll comment that out. And I'll comment out the same for the other display component. And now we can go through the steps of implementing the display service. So step 1, the injectable decorator needs to decorate the display service. And within the injectable decorator, to register the display service, I can add the provided in property and set it to root. And now there's only step 3 where we inject the display service. And I'll do the same. I'll inject the service into the other display component. Perfect. Now, as you can see in the browser, both the display component and the other display component are using the display service. And we can see the source. We see that the source says display service, and that source is coming from the backend, which display service has injected into it, the HTTP client. And if we look here, we'll see the data for HTTP client. And here indeed is the source property, which says display service. And each of the components are showing that source property. So now our application is implementing dependency injection, and each of the components are using the display service through dependency injection. Now, just to show you that this is indeed a singleton service, I'll go back to display component and let's console log in its constructor. Let's add a log statement that says display service constructed. And in the console, we see only one instance of that log statement, even though there are 3 consumers of the service. Now let's take a look at how we implement dependency injection when a resource is not a service, when it's not a class, but a value. And that can be a primitive value, such as a string or a number, or a reference value, such as an object or an array. The first step, we create an injection token for the resource. We'll talk more about injection tokens in a moment, but for now, an injection token is simply a unique identifier for the resource. Step 2, we create a provider object for the resource. And we'll also talk more about providers in a moment. But for now, a provider is a set of instructions, and those instructions tell Angular how to create the resource. Step 3 in the process, we register the provider. Remember, registering the provider simply tells Angular where you want the resource to be available and to what consumers. The last step, step 4, we inject the resource into the constructor of the consumer. And remember, we also did this for our service, but there's an additional piece of information that we provide when we inject a non-class resource into the constructor of the consumer. And that is, we have to decorate the parameter of the resource, the name of the resource. We have to decorate that with the inject decorator. And we provide as a parameter to the inject decorator the injection token that we created in step 1. In this implementation, we are using injection tokens and provider objects. Let's take a closer look at what these things are and how to create them. In Angular, everything has to have a unique name. Our components have unique names, our directives, our pipes, our interfaces. They all have to have unique names. And so too do our resources. Every resource in our Angular application has to have a unique name. And the way that we can ensure that a resource has a unique name is by creating an injection token for it. So how do we create injection tokens? Well, for services, it's quite simple. The class itself serves as an injection token. For resources that are not services or not classes, there's another way in which we can create an injection token. And that's by creating an instance of the injection token class. We call the constructor method of the injection token class, and we pass it a unique string. Now, it's optional as to whether or not you type the injection token, but it's recommended that you do indeed give your injection token a type. A provider is simply a set of instructions which tell Angular exactly how to create a resource. And how do we create a provider? Well, in the case of a service, the service itself is the resource. So Angular needs no further instructions on how to cobble together the resource. The service itself has all that it needs. So Angular simply needs to create a new instance of the service. And how do we instruct Angular to do that? One way is by passing the provided in metadata object into the injectable decorator of the service. When we pass this metadata object, we're doing two things. We're instructing Angular to simply create a new instance of the service, and we're telling it where to register that instance of the service. And when we set provided into root, we're stating where we want the service instance to be created is at the root of the application. So that's one of the ways in which we create a provider for a service. For other types of resources, we create a provider by creating a provider object. Let's take a look at the properties of a provider object. The provide property is the injection token for the resource, that unique name for the resource. And remember, that can be either the class in the case of a service, or the injection token instance that we create for non-class resources. The next properties are mutually exclusive, meaning you only use one of these in a provider object. And essentially, we use the useClass property when we want to replace one service with another service. We use the useExisting property when we want to replace the resource stated in the provide property with any resource that's previously been registered in our application. We use the useFactory property when we want to create our resource using a factory function. And a factory function is simply any function that returns a value. And that value can be a primitive value, or it can be a reference value, like an object or a function. We use the useValue property when we want to create the resource from an actual value. The dependencies property, or deps property, is an optional array of dependencies needed by the useFactory property. So we only use the deps property when we use the useFactory property. The multi property is a Boolean value, which states whether the injection token used in the provide property can have only one provider object that uses that token, or whether it can have multiple provider objects that use that token. When multi is set to true, each of the provider objects that has the same provide property injection token, they'll all be put into an array of provider objects. If multi is set to false, then if you register multiple provider objects with the same provide in injection token, it will override each of those provider objects until it gets to the last one in the registration. The default value of multi is false. The last thing that we have to understand regarding providers is how we register our providers. When we register a provider object, we're telling Angular which consumers, that is, which components and directives and services have access to that instance of the resource. There are two types of Angular application that we can create. We can create a module-based application which uses ng modules in its construction, and there's the standalone application which has been available since Angular version 14, and that uses both an application config object as well as routes to construct its various parts of an application. For both types of these applications, we can register a service class using the provided in property of the injectable decorator. And as we saw, when we set the provided in property to root, an instance of the service is created, and that instance of the service is used by all of the components and directives and services within the application. We can also set provided into platform, and this setting has a special use case, and it's used when we bootstrap multiple applications for our single page project. Setting provided into platform will make that instance of the service available to all of the bootstrapped applications within our project. Now, the other ways in which we register a provider object is by adding it to a specific provider's array within our application. For both types of application, both components and directives have a provider's array in their metadata. So components have a provider's array within its component decorator. For directives, there's a providers array within the directive decorator. And when we place our provider object within either of these providers array, we're making the instance of the resource available specifically to that component or that directive. For module-based applications, there's a providers array in both the application-wide app module, ng module decorator, as well as the ng module decorator for lazily loaded modules. And essentially, when we add our provider object to either of these providers array, the instance of the resource is available to all of the consumers, the components, directives, and services within that portion of the application. For standalone applications, we also have a providers array within the root level application config object, as well as within specific routes within a standalone application. Now that we have an understanding of injection tokens and providers and how to register providers, let's put all of this together and implement dependency injection for non-class resources within our demo application.